Okay, so, let's start off with, someone explain the difference between primary and remnant radiation. Go ahead.
Primary is when it comes from the tube before it gets to the patient.
Yes.
And remnant is what comes out of the patient to the IR.
Perfect. Okay. And okay, so photons. What would be the best way to describe what a photon is? Go ahead.
A packet of energy.
Yeah. Perfect.
Stop it, Heather.
Keep going, Heather.
I'm
You're
trying to
doing
write
great.
my notes still.
Can we talk slower?
Gosh dang.
There's some type of radiation that we would prefer not to get to the ion because we would call it undiagnostic. It doesn't carry any information. Scatter, right?
Can't make that fast.
So, can someone give me a definition of attenuation? Go ahead.
It's whenever the beam is altered by the patient.
Right, the beam is altered after it's passed through matter. In our case, it's the patient. So the beam that goes in is different than the beam that comes out the other side of the patient. It's been altered. It could be altered in different ways. It could be absorbed by the patient, or it could be partially absorbed and then scattered by the patient. Yeah. Okay. Oh, would someone like to define the difference between radio opaque and radio lucent? Go ahead.
Radio opaque is when you can't see through the image.
Yeah,
Radio lucent is clear.
right. And so, so with radio lucent, it means that the photons travel through that material easily, right? And if it's radio opaque, give me an example of a radio opaque part of the body. Bone. Ian's got it, bone. And do photons travel easily through bone or not? No, okay, good. You see we're going back to day one? I talked about this in class, I mentioned it a couple times, that whether it was images taken on film or whether it's taken with digital imaging, what do we call the invisible image once that information is there but before we can see it? Go ahead. The latent image. The latent image would be on a piece of film before it's processed, or it would be on a flat panel detector. Once it's collected all the charges and it's got a digital signal, before it sends it to the computer to actually put it together as an image. We call that the latent image. The image is there, it just hasn't been brought out yet. What are the prime factors? Go ahead. Go ahead.
Time, distance, and shielding. Yeah, shielding.
No. Someone else?
KVP, mass, and distance.
KVP, mass, and distance, right, and SID.
Which
Those
ones
are
is
the
she
prime
talking
factors.
about? Which are the three she's talking about?
Those are the cardinal principles.
The cardinal principles of radiation
Cardinal.
protection. You gave me the principles, yeah.
Cardinal principles are time, distance, and shielding. Yeah. And it's the
Okay,
prime factors for what?
Mass, KVP, and distance.
Thank you.
So, would someone define what SID means? Go ahead, Narita.
Source to image distance.
Source to image distance, right? So that would be from the source, what would that be? The tube, right? And to the image, that would be the IR, right? That's the SID. Oh. We'll skip the next question, but I can tell you that it's an application of the inverse square law. Someone define contrast. Go ahead.
Shades of gray.
Yeah, a little bit more. You're right, but a little bit more.
Are you asking like short scale and long scale?
Just contrast in general. Go ahead.
Higher KVP, more contrast?
Yeah, but we're not asking that, we're just defining contrast.
Is it like brightness or darkness, something like that?
Yeah, you
Brightness?
got it. What we're really looking for is the most basic idea of contrast is it's the difference between two densities, right? The difference between, contrast is different densities. So you got one that's really got a lot of density and it's black, and we got one that's got very little density and it's white. Together, the black and white, that's contrast. So you gotta have at least two shades to have contrast, and it's the difference in those densities. Yeah, just on a very basic level. And you'd be able to figure that out. You're gonna have to critically think a little bit too. How about the definition for detail? What's detail?
For me, it's clear.
The sharpness of the image.
It's the sharpness of the image. Yeah, that's one way of putting it. It's also like a distinct representation of all of the borders in the image. You can see, there's a number of reasons why you can see it, but you can actually see the different structures, right? Because then these are structural lines in the image. So it's, all you should be doing is writing down there, I need to know the actual definition of detail, right? Because if you look it up, it'll be very simple. So if detail is the true representation of the image, what is the definition of distortion? Just put a miss on the front of it, misrepresentation of the true object, right? So there are two forms of distortion. Can anybody tell me what they are? Go ahead.
Elongation and foreshortening.
Those are two forms of shape misrepresentation.
Image fog?
What?
Fog?
No.
Overexposure?
No. Magnification. Yeah, there you go. So it's magnification and magnification is size, is size distortion, right? Bigger gets magnified. And then shape distortion is elongation or foreshortening. So when we look at distortion, we look at two different types of distortion. One is size distortion, which is magnification. One is shape distortion, which is going to end up being elongation and foreshortening. Yeah? The next one is the law of reciprocity you have to calculate. The next one is application of the 15% rule. Remember, we go up, if we take the first picture and we say, oh, okay, we got okay density, but we just want to change the scale of contrast. If we go up 15% in KB, what do we have to do? Cut the mass in half. And if we go down 15%, double the mass, right. This is to maintain our density, right?
Oh, during the term, can we take out a paper before the test and like write down formulas?
No.
We just automatically in our head?
It's all in your head. Do they really let you, like, take your notes to test in
no,
other
not that.
classes or anything?
She's talking about writing it down on a piece of paper. Wow.
Writing it down all your formulas, so you have them right then?
No, when she
that's-
comes in, like just scratch paper.
Once she gets the test, she just puts her.
Yeah, no, you can pull out scratch paper to do your math and everything, but we're not doing any kind of, like, they call it whiteboard, where you can write down everything that's important and then refer to those while you're doing your test. We don't do that. You can pull out scratch paper once we start and do whatever, and write whatever you want on there.
How many math questions are gonna be on the test?
I don't know, so far it looks like 2 or 3, but I'm sure there's more. Oh, okay, the next one is also, it's an application of the inverse square law. Can someone define anode and cathode? Tell me what they do.
I just know anode is negative, cathode is positive. No, yeah, other way around.
Doesn't the anode send the photons through the tube?
The anode is positive, and it attracts the negative electrons. So let's go with this. The anode is positive, the cathode is negative. And these are the two most basic components of the tube, right?
Is the anode tungsten?
The anode is actually tungsten because it has a very high melting point. It also has some copper and iron in there too. There's a couple of alloys in there to facilitate heat dissipation too. But basically, where the electrons hit is tungsten. It's got like a 3,500 degree melting point. Okay. You can pass it on. Let's see. I'm gonna skip a couple of questions here that are in the quiz today. Because you got that quiz. How many, well, we're looking at voltage and amperage. Can someone explain what ranges we would use in our field? We're looking at current and voltage. What kind of units would we use in our field?
KVP and mass?
Well, KVP, so you're saying kilovolts, right?
Yeah.
So how many kilovolts is, how many volts is equal to a kilovolt? 1,000, right? And then the other we use milliamperage. So how does that compare with amps?
1,000.
A milliamp is 1/1000th of an amp. A kilovolt is 1,000 volts. Just to make sure we know what ranges we're in here. Okay. So let's talk about regulatory and advisory agencies. So who is the main regulatory agency for the United States?
NRC.
NRC, right? Nuclear Regulatory Commission. And for Arizona,
ARRA,
but let's be more accurate. Today it is
NRC.
Bureau of Radiation Control. So let's go back to initial radiation safety, and we made a distinction between the two different types of effects of radiation. We categorized them. What happens to a person when they're irradiated? We put them into two different categories: blank effects and blank effects.
Oh, stochastic?
Yes.
Not deterministic?
Stochastic and deterministic. So someone defined deterministic.
Those are the effects that can be seen in measured amount